Welcome to this practical demonstration of two non-destructive tests, the penetrant test and the magnetic particle test. Non-destructive testing has key advantages. It allows us to check components for cracks or flaws without causing damage, meaning that they can remain in service after inspection. The first non-destructive test we will carry out is the penetrant test on the side and face cutter. A side and face cutter is a type of milling tool designed with cutting teeth on both the edges and the sides, making it effective for machining slots and grooves. During cutting operations, the tool experiences cyclic loading. To optimize tool life and reduce the risk of overloading, feeds and speeds should be carefully adjusted to suit the material being machined. The penetrant test is a four-step process. Pre-cleaning the part, applying the penetrant, removing the excess dye, and finally applying the developer. To complete these steps safely, personal protective equipment must be worn. This includes a face mask to avoid inhaling fumes or particulates, gloves to prevent skin contact, and safety glasses to protect your eyes. The first step is pre-cleaning. Oils, dirt, or other contaminants are removed from the surface to ensure the dye can flow properly into any cracks or flaws that may be present. The side and face cutter is sprayed, and then a cloth is used to wipe down the component. Next, we apply the penetrant, spraying it evenly over the surface of the cutter. The dye seeps into the surface breaking defects, making them visible later in the process. To be effective, the dye must be left for at least 10 minutes before moving to the next step. After the dwell time, the excess dye on the surface is carefully wiped away using the remover spray and a clean cloth. This leaves the dye only inside the flaws, which will be highlighted in the following stage. Now a light coat of developer is applied to the surface. The developer draws the dye out of the cracks, forming visible indications. The part should be inspected after 2 to 3 minutes and again after about 20 minutes to ensure even the finest flaws are revealed. Here we can clearly see a defect detected during the test. The crack begins at the corner of the keyway and extends outwards to the outer diameter. This is a common example of a stress concentrator, where stress builds up in a sharp corner and leads to failure. Once the inspection is complete, the side and face cutter is thoroughly cleaned using a solvent and a cloth, returning it to its original condition. The second non-destructive test we'll carry out is the magnetic particle test, this time on a butt welded plate. A butt weld is created when two metal plates are joined edge to edge, and it is one of the most widely used weld types in fabrication. The magnetic particle test is a three-step process. Pre-cleaning the surface, applying the white contrast background spray, and then applying the magnetic particles under magnetization. Again, PPE is essential, including gloves, a face mask, and safety glasses to protect against sprays and dust. This tool is the magnetic yoke. It works by generating a magnetic field inside the component. If there is a crack or defect, the magnetic field is interrupted and the ferromagnetic particles gather at the floor, making it visible to the inspector. Just like in the dye penetrant test, pre-cleaning is critical. Any dirt, grease, or loose material must be removed to ensure accurate and reliable results. Next, a thin layer of white contrast spray is sprayed onto the surface. This creates a bright background that makes the magnetic particles easier to see. The spray must be allowed to dry before continuing. With the magnetic yoke activated, the magnetic particles are sprayed onto the weld. If there is a defect, the particles will cluster along the crack, clearly revealing it. To detect flaws in all directions, the yoke is applied both across the weld and along the weld line. There is a clear indication of a longitudinal defect as the magnetic particles are forming a line through the center of the weld. To obtain the most accurate results, the yoke should first be positioned perpendicular to the defect. For a complete inspection of the weld area, it should then be repositioned at a 45-degree angle to the weld line. As can be seen, there are no transverse defects. After the inspection is finished, The welded plate is cleaned thoroughly using a cloth and a solvent to return it to its original state. The magnetic yoke is pulled away from the sample whilst it is active. This removes the residual magnetic field in the material. Here we can see the defect detected in this test. A longitudinal crack running along the center of the weld. If left unchecked, defects like this can significantly weaken the strength of a welded joint. This concludes the non-destructive testing practical demonstration. If you have any questions, please reach out to your assessor.